Good morning and welcome, everyone. I am very glad that you are all here to help us celebrate the opening of the Ames Lab Solid State Nuclear Magnetic Resonance Center. We are glad you're here. We're glad that we have about a dozen folks here live and in person in Spedding Hall to celebrate what has been really years and even decades worth of work to get us to this point. We wouldn't be here if it weren't for decades of scientific development and advancement and leadership in the field of solid state NMR. I am so thrilled that we're here. It's been years in the making. The team of scientists that have been doing incredible NMR science on a wide variety of topics for decades has put Ames Lab in a position to be amongst the leaders in solid state NMR. At this point, I'd like to thank a few folks. I'd like to thank first Mark Kruski and the entire team of NMR scientists who have been doing the work to put us in a position to compete for truly world-class capabilities to do world-class science. I'd like to thank Department of Energy, who without their support would not have put in nearly $3 million to enable this renovation. And of course, I'd like to thank Facilities and Engineering Services for working through the preliminary design, for working through the bid process, bringing in a good contractor, and of course, being able to complete all of this work in the midst of the pandemic. So a big thanks to everyone here and all of those of you who have helped get this facility ready to go. At this point, I'm going to introduce Steve Hamilton, Chief Operations Officer, to extend his thanks and talk about the process. Steve.
Thank you, Adam. Good morning, everyone. Good morning, everyone that's online. Appreciate you taking time to join us this morning. I wanted to extend a special thanks to our local contract partners, and let me emphasize local. BBS Architects and Engineer were with us from the beginning in initial design efforts, and then stayed with us throughout the entire project for technical engineering support. So a big thanks to Rob, Megan, and Emmett for a great job. The other big local partner was Henkel Construction. Kyle Sievers was the project manager on this effort. His superintendent, Rick Johnson, they were here day in and day out executing on this project, brought it to fruition. Yes, as Adam mentioned, we had some challenges along the way in terms of COVID that created some supply chain challenges for them, but they were able to overcome that. And I also want to give a big shout out to our local folks as well. Adam mentioned the Facilities and Engineering Services folks. Terry Herman was the project manager internally for us, under the guidance of Doug, obviously, and the support that Vince's mechanics provided. Terry was the guy who actually put all the dots together to execute on the project, to work with the construction team, to work with BBS, to work with other stakeholders across the laboratory. Terry did an awesome job. And I know Terry's standing over here in the wings, and a great job, Terry. Thank you very much. Great job, well done. So in addition to FES, safety was a big portion of this effort. We had the COVID protocols that we had to put in place. About midway through this effort, we took about a 2-month pause. The construction team was very supportive of that pause. BBS was supportive of that pause. When we came back to work, we had new protocols in place. And all of the team members subscribed to those protocols, adhered to those, and I'm happy to report that we didn't have any COVID-related incidents on part of this construction project. And really, we didn't have any safety-related incidents as well. The other big team member was procurement. Andy Saxton, who oversees all of our construction projects and our contracts for our construction efforts, was no different on this one. He ran those weekly meetings to make sure that everybody stayed on task for the contract and helped us get it across the finish line. And the one big shout out that I also want to convey is to our NMR stakeholders. Mark and his team, they had the vision, they had the thought to bring this all together. We were happy to support in trying to make this vision come true. And congratulations to Mark and his entire team for this official grand opening today to open up the NMR Center. And with that, I'll bring Jamie Morris in for a few comments.
Hello, everybody. It's great to be here at the NMR Center this morning and great to be back on site for today. So this is an exciting development. At Ames, we really seek to provide the foundational science in the areas of chemical and energy conversion and translate that into critical energy technologies. And the vision of the scientists that brought this together really supports this. The ability to probe atomic configurations, distributions of configurations, and chemical reactions under surfaces in solids is really a huge capability. It's allowing us to probe, catalysis that leads to polymer upcycling. That supports our areas in discovery for sustainable science. The ability to probe the surfaces of nanocrystals, the edges of 2D systems, and relate that to their properties is important for our area of making every atom count. And the continued development of new techniques, new resolution, new fineness for kinetics of molecules. This is all part of our innovation for science that really is what makes Ames Lab great. So I want to thank all the scientists for their visions. I want to thank DOE for supporting this, and congratulations to everybody. So with that, I will introduce Marek Puski.
Thank you, Jamie. Good morning. Glad to see you all here. It's a happy day. If we sound a little bit today like we're delivering Oscar speeches, that's what it is. It's a time to thank you. It's a good day. On behalf of my colleague scientists who are operating in this new center, I'd like to extend our thank yous to a lot of people and organizations. I'd like first to echo Adam, Steve, and Jamie in thanking DOE for providing Ames Lab with the GPP funds, and Adam and lab management for directing those funds toward creating this beautiful modern research space. Thank you, Terry, Steve, Doug, Vince, Grant, many other people in the lab, and facility engineers and external contractors for putting their hearts and skills into completing this project. I also wanted to thank the lab management, Adam and Jamie, for their continued support of our solicited NMR efforts in many other ways, to advise, support, LDRD funds. Gratitude goes also to some past lab leaders, Alex King, Cynthia Jennings, Wayne Johnson in particular were helpful in bringing the first UMP system this way, and other instrumentation as well, with the generous support from CSGB and MSCD divisions of PS. So thank you all. As Adam already mentioned, the foundations, we should recognize that the foundations for this center are set on work that was done here over decades. In the early 1970s, Professor Bernard Gerstein started doing solid-state NMR in Ames Lab, in the chemistry department. And he is well recognized one of the fathers of modern solid-state NMR, and particularly high resolution of hydrogen in solids. Bernie was my mentor and remains to this day as my close friend. I also wanted to, meanwhile, at the same time, in physics department, Professor Richard Barnes started using solid-state NMR to study metal hydrides and ionic conductors, along with other energy-related materials. He was later succeeded by Professor Ferdinando Borsa, who is a world-known leader in applications of solid-state NMR in condensed matter physics. There are two other names that I'd like to mention, that Professors May Hong and Klaus Schmidt-Rohr, who were both faculty at the chemistry department in Ames at ISU, but were also Ames Lab scientists, And they have several years ago moved to MIT and yeah, respect. The, this is an astonishing list of names, which would be the strength of which would be hard to match anywhere in the world. And now this legacy is being carried on by a superbly talented group of younger scientists. We have here Frederick Perez, Aaron Rossini, and Takeshi Kobayashi, and also Yuji Furukawa. The new center will be is a home already of two modern solid-state NMR spectrometers for conventional NMR and a super sensitive DNP solid-state NMR. These scientists will push the boundaries of solid-state NMR, use these new experiments that they developed to study variety of materials that already mentioned by Jane, Adam, catalysts, polymers, nanoparticles, battery material, and numerous other classes of solids. Lastly, we are engaged in efforts to bring to Ames a new generation DNP in order to maintain and extend our abilities to characterize solids and maintain our leadership position in this area. And hopefully this new center will be a home for this system very soon. And with that, I think we're ready to make it official. All right. Here we go, gentlemen and ladies.
Okay. So you're gonna. So I'm going to give you a brief tour of the new facilities. So in here we have our dynamic nuclear polarization instrument. So while solid-state NMR can give us a tremendous amount of detail in various materials, it's very low sensitivity technique, and so that gets us some challenges when we're trying to study things like the surfaces of heterogeneous catalysts or the edges of key materials and situations like these. And so what DNP allows us to do is transfer a lot of the high sensitivity of EPR spectroscopy over to NMR by coupling the two techniques together. So this instrument here is a group of two superconducting magnets. One of them is the Gartron, which produces high frequency, high power microwaves, which we use to irradiate the electron spins and transfer ionization over to nuclear spins, for which we can then perform NMR experiments at 100 Kelvin. So this has been a tremendous success for us in the lab. It's supported our catalysis programs, polymer upcycling, materials characterization by solid-state NMR, among other programs. So if we continue to move in this direction here, we'll see the rest of our instruments. And in here, what we have is our two conventional solid-state NMR spectrometers. So we have a
400 megahertz spectrometer in the front, as well as in the back with a 600 megahertz NMR spectrometer. So both of these spectrometers are equipped with some unique capabilities. For example, the 400 megahertz spectrometer has the hardware that enables us to do in situ studies with high temperatures and high pressures for example, analysis studies. The 600 megahertz spectrometer is equipped with an array of fast MAS probes, including a 0.75 millimeter probe that allows us to access the highest steering speeds available at the moment of 100 kilohertz, which provides the highest resolution possible, for example, for proton spins, and enables a lot of sensitive proton detected experiments and the proton detection of insensitive nuclei activities. So this space was created with forethought in mind. So where we are standing now is where we plan to install in the future a second generation DMP system that will operate at 30 Kelvin instead of 100 Kelvin, and at a higher magnetic field of 14.1 Tesla. So we're already equipped with all the necessary hardware, so we're just waiting for the chance to install this basement space.
Okay, any questions?
Not yet.
Just want to say thank you all again for joining us. We are thrilled that we have this new space. The team's thrilled. They've been in here for a month or so, getting the experiments done, and we are working hard, preparing to make a compelling argument, come up with those science drivers for why Ames Lab should be the home of the next greatest solid-state NMR institute. So again, thank you all for joining us. Hope you have a great rest of the day. Bye, everyone.